All right, our next speaker will be Jim Reuter, who's the Associate Administrator for Space Technology at NASA, and he will be giving us an update on what's going on with space tech. Thank you so much, Jim.
Oh, yeah, thank you. It's my pleasure to be here, and I really appreciate all the participation that we're seeing here, really in the consortium as a whole, and today in particular. I've got just a few charts that I thought I'd talk about, give an overview of space technology and how it's fitting into why we're here today. If you could go to the next chart, please. What I like to say is the strength of our organization is the breadth of our technology investments that we have, anywhere from, and this represents those major categories of technologies that we drive our investments for space technology, starting from early stage innovations is concept studies like NIAC, research grants for universities, and internal funding also that's kind of a bid and proposal type money, R&D proposal rather. We run the technology transfer program for the agency. We do most of the prizes and challenges. We'll talk about that a little bit as we're going along for the agency. We run both the small business innovative research and the small business tech transfer, and we'll talk about how we're engaging those. And tech maturation, we have a game-changing development program, and that's where we house, if you will, the Lunar Service Innovation Initiative. But that initiative is something that's not a program, but it spans across our entire portfolio and really across NASA of activities that lead to a common purpose. And then we do higher technology readiness, flight demonstrations, system demonstrations, as well as small suborbital flights and small spacecraft. We're up well over 800 flights that we've had in flight opportunities over the last 10 years or so. And so about every 2-3 weeks, we're flying something. If you could go to the next chart, please. And so, and like I say, what we really try to do is take advantage of that entire portfolio and focus on problems, just like LSII. I won't spend a huge amount of time on this chart, but it's just meant to give kind of a hodgepodge of the types of things we do. Here's some highlight things. I'll start in the upper right corner because Mars 2020 Perseverance, tremendously successful. We had 4 of the technology deliveries for that flight. And they're listed there. Medley 2 and all enormously successful. Medley 2 and terrain relative navigation were during the entry and landing phases, descent and landing phases. Medley 2, we gathered a lot of information from the aeroshell, pressures, temperatures, heat fluxes, a lot of data that we've learned that can feed into the next design of the next Mars mission, as well as other planets. Terrain relative navigation enabled, it was, using maps inherent in the eyes of the spacecraft to land and avoid hazards. Tremendously successful. It pinpointed its landing spot within 10 seconds on the first try. And allowed us really to get to the very interesting Jezero crater and avoid hazards along the way. Meta it's a Spanish provider that we supported, and it's a weather station basically. It's been used frequently and is integral to the use of the Ingenuity helicopter. And then finally, MOXIE has operated now very successfully and has created oxygen from the carbon dioxide of the atmosphere of Mars, and it's the first demonstration of an ISRU from another planet. We also, these are things, I'll talk about the things that we're doing on the moon, but on here, I just thought I'd pick a few of the others out. Laser communications relay demo, we're ready to fly June 23rd to 25th on a STP-3 mission. We've got a number of cryogenic fluid technology flight demonstrations now awarded and begun in work, along with a lot of us subsystem levels. We have a small spacecraft, 12U, that we call Capstone, that's going to actually demonstrate the NRHO orbit this fall. And it's a great orbit for the Gateway Station, but we've never actually operated in it, so this will be a good chance to get some early data. We'll talk a lot more about the CLIPS missions and the activities that we're doing in LSII. Solar electric propulsion, we're going to the critical design review. We're qualifying the unit, the thruster that's going to power the power and propulsion element as we go. A number of other things as well. Deep space optical comm is the last one I'll point out, and we're almost ready to ship that for integration into the Psyche mission for a launch in August of 22. So just a few things to give you a sense of the types of things we work on and are doing. Next chart. And I won't spend a huge amount of time on this, but when we guide our investments, we have what we call our strategic technology framework that guides the investments for space tech. And with that, there's 4 strategic thrusts that we've defined: rapid, safe, and efficient space transportation, which we call GO; expanded access to diverse surface destinations, which we call LAND; sustainable living and working farther from Earth, which we call LIVE; and transformative missions and discoveries, which we call EXPLORE. From these, we've defined outcomes that would drive what we're trying to achieve. And with that, then we've identified 14 or so capabilities that are needed to achieve the outcomes. Those capabilities are color-coded on this chart in little circles. But the main thing I want to focus on is that what it also kind of tries to display is the types of things that we do where the moon can be is a critical part of what we're trying to do for exploring the moon, as well as feed forward to Mars. Not everything we do feeds forward to Mars, like the nuclear technologies or landing very heavy payloads, but a lot of things do, and a lot of those are caught up or wrapped up into the Lunar Surface Innovation Initiative, which includes things like the sustainable power and surface utilities, in situ resource utilization, survival in extreme environments, autonomous excavation and construction, and so advanced robotics. And throughout these next 2 days, I know we're going to have lots of talks about those. I'm looking forward to hearing from the focus groups. It's my chance here to also find out what's going on in more detail than I normally get in my daily life. So I'm really excited to hear all the progress you've made, and the participation has just been wonderful. Next chart, please. So what we've been doing, especially over this a little over a year, 15 months or so, is when we kicked off our Lunar Surface Innovation Consortium. And since in that time, since we've really kind of established, we tried to put together a chart of what have we awarded and what have we been talking about. And that's what you can see kind of on this chart. First, I'll just talk through maybe not every single line, but just to give you a sense of it. We've awarded over $200 million now using our broad range of our space tech programs, and to establish collaborations from industry and academia. This number is probably actually a little bit of an undercount because we don't count things where some of our NASA centers are leading and they're still using the community in developing things that fit into this architecture. But the CLPS payload services, the commercial lunar payload services, is a great opportunity for us. We think it's a fantastic program that's been really successful. One of the missions that we have coming up is the Prime 1 mass spectrometer and grill. It'll be the first use in a pole environment and detecting for ice water. On that same flight, we have a Nokia 4G wireless and also a deployable hopper from Intuitive Machines on that flight. So it makes a really nice early flight. I think by the end of next calendar year, it should be flying. We've used our tipping point and collaborative opportunity acquisition calls and those are generally annual calls for us. We had a number of topics that feed directly into LSII, and we picked about $127 million worth of activities for that. 10 tipping points and 5 collaborative opportunities were selected in the last year. And what I would say is that does not count things like the cryofluid management flight demos, which do have a tie to the moon, but is not directly part of the LSII. So this is $127 million, predominantly for industries. We heavily use our SBIR program, about $36 million of activities there. We established the normal phase 1s, phase 2s, phase 3s. The civilian commercialization readiness pilot program is a great program. It requires matching fund is one of the post phase 2 activities. And we can go up to, I think, $3 million on those awards with matching of another $3 million. And then what we call our lunar sequentials is one we also introduced this year. It's actually a phase 2 sequential that we got approval for with a focus on really the lunar surface activities. And with that, we awarded several last year, and we can award up to $5 million per award. Our research grants, we announced here at this forum last February 28th that we were going to establish a new research grant program that we called Luster. It's a lunar surface technology readiness opportunities. And we've done that and announced our first 6 winners of that over this past year. Established it and got it out and awarded, along with our early career faculty and early stage innovation type awards that we do there. We still have some next step BAA ongoing with 9 ISRU awardees. We also had a solicitation that we just awarded 5 phase 1 awards for vertical solar array technologies. This is a concept that when you're operating on the poles of the moon, by the nature of it, the sun is always right at the horizon, and so it's very hard to get a good incident angle to generate power from the sun. But if you go high enough, if like 10 meters into the off the ground vertically, and have a vertical solar array, then you can greatly improve that incident angle and generate a lot more power. So we've got 5 great concepts for that, and we hope to actually fund a couple of them post phase 1s for development. Even our NIAC program for studying concepts, advanced concepts, and revolutionary concepts, one of our awards there is going for exploration of lunar pits, and we hope to fly that sometime in this decade. We have a number of activities that have an educational bent as well. Our Big Idea Challenge, Breakthrough Innovation, Innovative Game Changing, so even big is an acronym. We had two different activities. We always have two going on in parallel. Our 2020 item award was for permanently shadowed regions, and we had 8 teams there that did a great job. And currently now it's dust mitigation with 7 teams going on. We do a lot of things at NASA tournament labs, open source challenges. The Yet 2 is a great platform for us. Hero X has done some great things for us, including identifying a honey-eyed shrunk the NASA payload challenge, where we had some really great ideas on things that could fit into a little bit bigger than a bar of soap. And we have a lot of small rover scouts or even hoppers that could potentially be used on. Centennial challenges, we introduced a number of challenges. A couple of them are the Watts on the Moon and the Break the Ice challenges, which you can probably guess what the subject of those are. The Watts on the Moon is getting ready. They're both in phase 1. Watts on the Moon is getting ready to complete, and we should be announcing the winners there fairly soon. And then finally, of course, the activity with Johns Hopkins APL, a great activity. This has been and it spawned this event, as well as systems integration activities. So next chart. And then this is just we're really trying to leverage the early lunar missions to accelerate development of core surface technologies. And we have 6 focus areas. You'll be hearing from each of those focus groups as we go on today and tomorrow through this thing. And they're shown here in the different swim lanes and represented, at least in terms of the types of things that we're planning on doing as we're going forward. The prime, in the upper left, the prime will be a drill in mass spec that's looking for an ice mining demo and feeding forward into the Viper, the Science Mission Director led Viper mission as we go forward. And later on, we're also in parallel, we're developing oxygen extraction capabilities from the regolith. And then we hope to demonstrate that, as well as ultimately leading to a pilot plant demonstrations somewhere towards the end of the decades, actually, depending on appropriations. Surface power is a great area. It's a critical activity for the things we need to do on the moon. And a number of activities like regenerative fuel cells, wireless charging. We're actually going to have a workshop, I think, coming up on on power beaming, which is a great deal of interest, the vertical solar array technology that I talked about earlier. And ultimately, we hope to develop a fission surface powered mission as well, and on the order of 10 plus kilowatts. Dust mitigation is a critical thing to get together with both the designers and scientists, and we have a number of activities there for demonstrations and characterization on the moon. Extreme environments, we have a number of activities that are with including the what we call cold arm, which is looking at a number of different technologies for surviving the lunar night and reducing power needs, basically for improving the operating temperatures of items, as well as what we call a lunar thermal toolbox, materials demonstrations, very similar to the MISSI demonstrations on platform on ISS, and so on, leading to just lunar night material survivability as we go along. Extreme Access is a place that we have some really creative stuff going on surface robotic scouts, and those become platforms, as we said, for other payloads. And demonstrations as we're going on is kind of an outline there. We had intended for a deployable hopper to be something that was a little bit longer term, but we had a great proposal, so Intuitive Machines has a hopper that we have on one of our early flights now. And so we're really excited about how this works together. We had our NASA leads in each of these areas are integral, or we want them to be integral into the process that you're going through for each of the focus groups that we have here, and we're really excited about where this is all going. So next chart. Then it's been quite a 15-month stretch or something like that. It was really last September where we said, okay, we gotta do something. We want to establish a Lunar Surface Innovation Initiative, and we need to do something to bring the community in, have a great a forum for coordinating ideas, for receiving ideas from the community, and relaying back an information change. And so we're really excited about the Lunar Surface Innovation Consortium has come about. We had a lot of different concepts, honestly, when we were thinking about this, and we're excited with the work that APL has done, and really the entire community, how you've gained. We have over 1,000 active participants from over 300 organizations across 44 states, and it's really increasing. It's maintaining its interest. We're over 300 participants here today so far, and I think we had 700 registered. So really exciting numbers. And our representation in the pie chart and across the country, you can see, are very good, and with a nice healthy mix with industry, academia, nonprofits, and so on. But we've had this is our third consortium meeting with a national kickoff last February, doubled the attendance last fall, and then a spring meeting here today. We've had 3 workshops over this time, and ISRU supply and demand, bringing the people that potentially to be suppliers versus demand of things like oxygen and water and so on. A dust mitigation workshop, bringing the community together on that to talk. A lunar mapping, bringing the people that have to perform precision landing with terrain relative navigation with the people that potentially would be the mapping and understand that from a science standpoint. As I mentioned, we announced the Luster as a new activity last spring, and now we've got 6 awards. We've done APL has conducted the Lunar Surface Power Report, a Lunar Surface in ISRU system integration assessment, and a simulate assessment. It's really a complex thing, actually. Do we have the availability of existing simulants that we can use? So really an outstanding activity that's going on. I can't tell you how excited I am to be here and the progress that's made. That was really more than I really imagined it would be even just a year ago. And then finally, next chart, please. Just a summary by the numbers for Space Tech. We evaluate, typically, this is a typical year for us. This was FY 2020 dollars. 3,700 proposals, over 900 proposals we select, over 400 active university partnerships right now with over 100 universities. We have over 140 planned flight demonstrations. We have over 1,400 active technology projects. We've issued over 150 patent licenses to companies with over 500 industry collaborators And if you count a transition as something that we stopped funding, but somebody else picked up, there's been at least over 900 since, that takes a little while, so since 2011. With that, I'll turn it back over, and I'll be glad to take a question or two if there's time.
Am I back on? Hello? All right, excellent. Thank you so much, Jim. That was fantastic. We do have a few questions in the chat. The first one that came in was, how soon might we see the next round of tipping point announcements?
Yeah, that's a good question. I'm excited about that one too, or interested in knowing. What I would say is our budget was flat between 20 and 21. It wasn't everything we were hoping for. So we got that one out, but we're not going to be able to put one out and probably until FY22. But I do hope to get, we'll see where the appropriations goes, but I hope to get something that we'll be able to put out in the early part of FY22. So, and then award later in the year. But we'll see where the funding goes.
Excellent. And that FY22 is not that far from now.
No, it's fine.
Time is a little weird right now, but yeah. All right. The next question is, can you extend the vision to go, land, live, explore, use, and include technologies for funding and using cislunar and lunar resources to add value and opportunities for humankind? I guess that's add.
Well, what I would say is I'm not sure I quite followed the question, but what I'll start to answer and then see if I'm on the mark or not. What I would say is the use in that framework. GO is naturally the transportation systems that get us there. Land are the things. Okay, we want to access the moon and Mars and other planets, and what are the technologies we need to land there, or even return things back to Earth. Live is the one where we house a lot of the activities that are to establish a presence of humans and robotic on the moon and then onto Mars. And so the things that we're talking about there is the utility. If you could see our outcomes and stuff, is a lot of those things. The outcomes are covering those things that were being talked about here. And in fact, that chart that I showed with the Earth, Moon, Mars. If you look at that chart, there's a lot. The activities that make up LSII are very heavily what we focus on live. And then explore is another one that's also integral here, because if we develop surface scouts, robotic scouts, autonomous systems, and so on, those things we kind of group under explore. So with the framework, we can adjust the outcomes depending on the priorities, and I think we cover everything that was being talked about in that list.
Excellent. Here's a good one. How can industry collaborate with academia and small businesses to make STMD most successful?
Yeah, I love that. Please do. In fact, one of the goals we had of establishing this consortium was just that. I want to, the large businesses. I think it's also an opportunity for you to help guide and mentor the folks that are there. Some of you, I know a lot of you are already doing that, but what we also try to do is when you look at our solicitations, we often encourage, an industry interaction with it. The Luster in particular, it was set up to do that. And even, I don't want to lose, even our early career initiative that we do within NASA, we have that's a internal NASA early career folks, but they have to do a public-private partnership. So it's always another university or a small business or something that's with them. So we're trying to make that a lot of opportunity, and I want to set the expectation that that's what we're looking for from industry to help us.
Excellent. All right. Well, thank you so much for joining us, Jim. It was a pleasure to have you as always, and I think that really sets us off with the impetus for why we have the Lunar Surface Innovation Consortium. And I think what's really important, and I apologize for not providing this intro at the very beginning. We were having a little bit of turbulence here, but we are trying to draw in the community, harness the energy of the community, get these discussions going, and really serve as a conduit between NASA, Space Technology Mission Directorate, and the community to help people understand what's out there, what technologies are out there, what do we need as a nation and as a world to really build to this future. So that's a lot of what we're going to be talking about throughout the rest of this meeting and how all the different pieces can come together. So I would like to belatedly thank everyone for coming and joining us and for all of your efforts over the last year, because this has been really amazing to see the kind of engagement we've had from the community. So thanks again, Jim.